You know, I don't think I did choose. Yeah, I think my whole career has been a series of random events. I think it still is. So I think if you told me when I was an undergraduate student that today I would be giving a talk to 800 people in Nantes in France and talking to them about new methods in NMR, I'd have certainly told you needed urgent psychiatric care, and that was the. So I certainly didn't see that coming. It wasn't part of the plan. The plan was actually something else at that time, and ended up back here. Obviously, NMR was hanging around in my family, but I'd actually spent quite a lot of time trying to avoid doing NMR or science in general. So I think my idea is that there's a lot of luck involved in any kind of trajectory through life and career. So good luck, bad luck, I don't think you need to qualify it, but it's all done by accident. So. So that I do remember. So that was in Lausanne. I joined Jeffrey Bodenhauser's group, and so one of my teachers there was Steve Wimperis. He was finishing his PhD, and he introduced me to the spectrometer. It was a 400 wide bore with something like an Aspect X32 type console, and basically we went down and he introduced me to the spectrometer and said, okay, well, what you have to do now is shim it. And I think we had about 3 days of spectrometer time available. He said, shim it, get back to me when you're done. And I think it took me about 3 days to shim the spectrometer. So that was all I did. That was my first experiment, was just shimming the NMR magnet in the old days. Again, I think it depends on how you define success. So one of the ones I liked the most was an early experiment, again, that we did in Jeffrey's lab, where we detected and understood what we afterwards called the transient Bloch-Siegert shift. And that was an example where initially we had no idea what was going on. It was actually something that was interfering with what we really wanted to do. But I think what was nice there is once we worked out the idea, we were then able to simulate it using some very simple Bloch equation simulations. We've got exact agreement with theory. So I thought that was kind of a success story in a way. It's a mini success story. I'm not sure how many people care about Bloch-Siegert shifts. The obvious one now is the introduction of DNP sense experiments to look at surfaces, which we did in 2010. I think that's obviously becoming the most successful experiment we've ever done, and it's a very exciting experience to go through that. Again, it's very difficult to know what the mistakes were. I don't think there haven't been any magnets that quenched directly because of me. But on the other hand, many experiments have not worked out. So most of what we try and do doesn't work. So I wouldn't really qualify that as mistakes, but they don't usually work. And I'm still hoping that some of the most important failures, let's call them like that, the most important failures can be turned around, and maybe we'll make them work in the future. So if I told you about them, I'd have to kill you afterwards. Mostly my wife. I don't always take it. I probably should. Okay, so never take the easy way out, I think, is one of the main mottos. Is we should always be looking for difficulty. I try and tell them that they should keep chipping away at problems with patience and determination. I often tell them they don't come here to do something easy. And on the other hand, I think what they would recognize is go forth and conquer. behave. I thought this was an interesting question. I would say, of course. So, and this is a question that comes a lot. So, I mean, the real question to you is, why wouldn't it? You know, as long as I've been doing NMR, people have been saying that different versions of some version of the field is dead, or it's all just applications. And I think that's just very short-sighted. I mean, the field has always been based on applications. NMR spectroscopy is to detect structures of molecules. It has little or no interest in itself, and I don't see that changing in the future. And those applications are what drives a very vigorous field that keeps on evolving. So I have confidence that will keep going. That's tricky. You know, this is the kind of, I have a daughter who's now a 24-year-old medical student, so that might tell you something, but don't know if she listened to me. What I choose, I think, is almost certainly not what one should choose. So, you know, asking my opinion is not a good idea, because otherwise I would be an Apple executive, because I certainly didn't see that coming. I was sitting right next to the boom in Silicon Valley and Berkeley in the early 90s, and I decided to go and do a postdoc in solid state NMR. That was very short-sighted, obviously. You know, don't regret it. Certainly not good advice. Some of the keywords that I see around me today are things like data, medicine, sociology. There's some kind of revolution going in sociology. Interactions in the general sense. So I think artificial intelligence is an obvious choice today, but again, it might be too late already. You know, the really clever people have already gone into AI. So if actually what you're asking is really what would I do in physical sciences, then there's a materials revolution in chemistry which is only just beginning, and I'm pretty sure of that. I think that materials is in roughly the same situation as molecular chemistry was 100 years ago. And so there's 100 years of kind of materials revolution ahead of us, and this will be driven by, you know, atomic level understanding and control. So NMR is there for that, you know, and the challenges related to energy and health are just phenomenal. So that's what we're focused on today in my group, and at least that would be self-consistent advice, I guess. So what do you think?